Hello everyone, welcome at this session on Azure Digital Twins in a nutshell. My name is Mihail Mateev. I'm Microsoft MVP for Microsoft Azure and Data Platform, member of Microsoft Regional Director Program, and also PAS Regional Mentor for Central Eastern Europe. Before to start, don't miss to explore everything which PAS has to offer for you, and you just need to visit pass.org for this. Your feedback is very important for us as speakers and also for PAS Summit organizers. So it will be great if you are able to submit your feedback. If you do this before 20th November, you will be able to win some prize. Feel free to contact me in social networks if you have any questions around Azure IoT or Azure Digital Twins service. For more information, you can visit my personal website, and also you can take a look at my blog related to resources around IoT and digital twins. Current session will include several parts. First, we will have introduction to Azure Digital Twins and Digital Twins concept. We will talk about digital twins in IoT projects. We will also compare different implementations of digital twins. We'll compare device twins and Azure Digital Twins service. After that, we will talk about Azure Digital Twins in modern IoT solutions. We will go in details how to define spatial model, and at the end, we will have some interesting demos. For those of you who have no experience with digital twins concept, I will provide some introduction to explain digital twins concept and how exactly this technology is changing IoT, artificial intelligence, and some other areas from the modern industry. Actually, digital twins concept is not new. It is from the early 2000s when Dr. Michael Greaves proposed simulation related to software systems and more specifically from product lifecycle management. So this was the first proposal related to such kind of context. Later, this type of concept stay very popular also in aerospace and defense, and step by step stay more popular in different business domains. When we talk about digital twins, we need to know several terms. Digital twin prototype is exactly when we have digital twins replica before to have the original system created. Digital twins instance is digital replica of existing solution, physical or virtual, and digital twins aggregate is a replica which is used to aggregate results from several origin solutions. Digital twins aggregation is used mostly when we need to have some analysis about prognosis and learning related to existing solutions. In general, the specific information contained in the digital twins is driven by use cases. The digital twin is a logical construct, meaning that the actual data and information can be contained in other applications. It is interesting to consider how to describe digital twin because it is something which will help us during the next stages of this presentation. So digital twins are virtual replicas of physical devices and also virtual systems which can be used for simulations before these original solutions to be created, but also digital twins can be used for different analysis during the product life cycle of these systems. Digital twins are tightly related with technologies like Internet of Things, artificial intelligence, and analytics because digital twins is some kind of integration between original systems and different services for analysis. We can say that digital twins is part of mixed reality, but we relate this technology a lot with IoT and AI exactly because it offers options to integrate easy these services which we have in the cloud for analysis with uh, original systems having such kind of virtual model. How does digital twin work? From one side, digital twin can be created as a replica of already existing solution, but from another hand, it is possible to be created in advance, to be used like prototype and to be used for simulations of the prototype and also for additional simulations when we have to analyze behavior of existing model and to make reconfiguration. In such kind of analysis, it is possible to push back to the original system updated configuration based on analysis done with the help of digital twins. Nowadays, digital twins concept is applicable in almost all business domains, but probably is good to mention several areas where really we have a good experience based on digital twin solutions during last 2 decades. Energy models for optimization and smart energy is one of the areas where you can have simulations and prototyping using digital twins. Another important area is analyzing of complex structures. It is part of construction and everything around complex structures can be analyzed and monitoring in this way. Additional, you can have structural help monitoring regarding to different specific cases around human safety, about maintenance cost, and it is possible to optimize continuously configurations related to specific settings for complex important constructions. Materials testing is another area where you have good options to use digital twins like concept. You can see digital twins in real world as replica used for maintenance of complex machines in different domains. So it is something which is really nowadays very important in the business. Almost all complex machines offering nowadays are used in similar way. So you have digital twins replica, which is used from manufacture to be able to observe the behavior of the machine and to provide maintenance. Digital twins is also very important for sales and marketing to be possible to track existing solutions which are already available in the real world. I mean, some kind of instances of complex machines or structures, and it is possible to have analysis on the market and to propose new features based on what you have as information from the behavior of the current items and also their owners. If we talk about digital twins, probably is interesting that we can consider digital twin platform, which is in the middle between smart connected products and specific digital twin services or services which are tightly related to digital twins functionalities. So in such kind of solutions, we can have from one side smart connected devices, part of different products. We can have specific twin services which are used for design, for analysis, for deploying of new configurations, for different real world solutions, and in between, it is good to have a platform which offers all these functionalities to be possible to not build some monolithic digital twin services, including everything, but to have a platform on top of which to provide specific functionalities. Exactly such kind of example is Azure Digital Twins service, probably the only one uh, publicly offered digital twins platform which is on reasonable cost and available for everyone. It is important to know difference between platforms for simulation and prototyping from one side and digital twins from another side. So we will talk a little bit more about details, what is different when we have simulation platform and what we have for digital twins platform, and also about prototyping. We will have short comparison between building information modeling approach and digital twins concept. If we compare simulation models and digital twins, we have from one side the same type of sensor data, and from another hand, we have in simulations generation and manipulation of data as part of the simulation. So we have something which can be happen but not happening at the moment. When we have digital twins platform, we have bidirectional synchronization. So from one side, we can have simulations using digital twins platform, but from another hand, we can have injection of data from the original solution, which is replicating on the digital twins model, and we can have flow in both directions, from the original object to the digital replica, and from the digital replica to the original object. So when we have digital twins, we can use it also for simulation, but we cannot use simulation models for bidirectional communication during the product lifecycle. When we talk about modeling and prototyping, there are different platforms. We will consider building information modeling approach just because it is quite popular. So if we compare BIM with digital twins, when we have prototyping and modeling, actually we have something which is used during the design phase. It is not used during the product life cycle. This is the main difference between platforms for prototyping and digital twins platforms. We can use digital twins platforms also for prototyping, but we cannot use platforms for prototyping for real life communication with the original solution, bidirectional connection, simulations and analysis during the product life cycle, and maintenance. So this is the main difference, and this is exactly what we have in digital twins additionally than a very popular platform for simulations and modeling. You can see more clear the comparison at this schema. We have from one side this uh, BIM platform where we have conceptual design, and it is also used partially during the construction. And we have digital twin where additionally we have operation and maintenance during the end of life cycle of specific product. Let's now talk about digital twins in IoT projects, because IoT is one of the areas where really we have a very good application of digital twins concept. We have tightly connected from one side IoT solutions and digital twins platforms, which allows these solutions to be integrated with different analysis services. We can consider digital twins like integration layer between physical things from one side and different information systems. This is something which allows in real world to have a very simple connection between physical and virtual systems which has no idea for analysis services used for different kind of analysis, and also different information systems mostly related to different kind of analysis which can has no idea about some specific in physical things. So digital twin could be like a platform which connects these different components, physical and virtual solutions like original systems, and different kind of analysis systems which can be not configured to be exactly used for specific custom use case. In this way, we can have fully functional solution with digital replica where digital twin platform actually allow us to have pretty easy simulation using services which are not designed especially for specific use case. So we can have different components with common purpose for different kind of analysis and one common platform which can be configured and connect everything in one common solution. Most of the cases are related currently with state of different devices which we have in the real world. And quite often people ask why we need to have such kind of platform, why we do not have solutions which are custom, case by case. As you saw in the previous slide, the most important is that we have common platforms, so we can have more formal approach for modeling and integration. If we have custom solution, case by case, we will have more expensive solutions, we will have longer time to market, and we will have higher complexity of our solution. So this exactly explains the business value of digital twins platform in our real life solutions, especially for IoT. IoT is one of the first places where you can see implementation of digital twins even in more simplified format. Quite often it is related to state of the devices, and we have simplified solutions which are focused mostly to have a replica of the state of different devices. In Microsoft world, for Azure IoT, in IoT Hub, we have similar solution named Device Twins. The difference is that Digital Twins offers common concept for everything. Device Twins is mostly focused on what we have related to the state of devices, synchronization and replica of the state of devices. And we have for IoT Hub specific device registry where we have information represented in this way. Device twins is mostly related to synchronization between state of the devices, which is the current state at specific moment, and desired state from the backend when we want to reconfigure these devices, when we want to install some software or to have some different specific cases which need to change the device state. When we compare device twins to digital twins, we can see that this fully functional platform covers much more details. And for example, Azure Digital Twins includes special intelligence graph, which offers opportunity to have quite complex models inside this platform. It is possible also to harness IoT devices, to be possible to collect information. It is also possible to have quite complex role-based access control and multi-tenancy. And in the end, we have quite rich integration with different services like events hubs, service bus, event grid, time series inside, and other services. It is good to clarify several additional details about the difference between device twin and digital twin, which is quite important. So from one side, we have device twin, which is mostly like key value flat representation of desired configuration and reported configuration of devices. And we have quite simple structure here. We have no very complex model. From another hand, digital twin is a graph with rich semantics, and it is applicable not only for devices but for almost everything from the real and virtual world. Device twins is a simplified version of digital twins, mostly related to IoT hub and specific cases which we have around configuration of devices and also around software update. Digital twins is a concept which is applicable for everything. So this is the most important difference which we will consider also later in this presentation. Another important point is to know more about IoT platforms powered by digital twins, or in another way, to have some comparison between different cloud vendors uh, who offer specific IoT solutions. If we consider the main players on this market, you will see that all these vendors explain that they offer solutions related to digital twins, including, of course, Microsoft with Microsoft Azure, AWS, GCP, IBM, Predix, and some others. But if we go in details, we can see that actually no one offers uh, software as a service representing digital twins platform. In GCP, you have no any specific components dedicated for this solution. You have just separate services which you can combine with custom development and to build custom solution based on digital twins concept. This approach requires a lot of effort and you will have quite long time to market. So regarding to this, you have actually custom development. You have nothing out of the box, nothing predefined which you can have. In AWS, you have similar to device twins, simplified option for IoT, which is named device shadows. It is quite similar to device twins with some specific features, but in general, this approach is mostly for configuration of devices, mostly for tasks related to device software update, changing of configuration, and having some relative not complex rules, custom rules, which you can apply for this model. This implementation is mostly on device level, and we can go a little bit more deeper in AWS to see what they have as solution for digital twins as a platform. There is no specific solution again. You have different services. You have AWS IOT Core. You have Amazon Sumerian, which is used for uh, different models. You are using also different services for analysis, but no one common platform which can be used out of the box. In Microsoft Azure, As we already considered, from one side we have device twins, part of Azure IoT suite. This solution is quite similar to what Amazon has, but from another hand, we have Azure Digital Twins service, which is completely new solution. It is Digital Twin software as a service. These solutions support large, complex digital models, events, and custom logic. This solution is fully configurable. It is Industry 4.1 ready. It is still in preview, but we have already second preview with a lot of features, and the solutions stay better and better. Next slides will be dedicated exactly to what we have in Azure Digital Twins service. Let's first take a look at the features from the first Digital Twins service preview from 2018. It is actually a service which will be deprecated at the end of 2020, but the first version offers several important features. Digital Twins object model. It was possible also to use spatial intelligence graph, advanced compute capabilities, data isolation, multi-tenancy, security, integration with Microsoft services. What was specific in this service is that from one side we had Azure IoT Hub in the core of this service. Nowadays, for the second preview, we already have Azure IoT Hub separately, not as part of Digital Twins, which give us much more flexibility currently. But we had also some options related to vertical solutions. So Microsoft offered Azure IoT Solution Accelerators, these preset templates based on Azure Digital Twins, and Azure IoT Central, which also used Azure Digital Twins. So as you see, actually Azure Digital Twins service from 2080 was tightly coupled with several other components from Azure IoT suite. If we take a look at the whole Microsoft Azure IoT suite, you can see several places where digital twins is applicable. One part is Cloud Gateway, or what we have as Azure IoT Hub. As I explained from the first preview, it was just common solution where we have IoT Hub and Azure Digital Twins together. So it was possible to use Azure Digital Twins as gateway service. Nowadays, you again need for some functionalities from the latest preview, Digital Twins and IoT Hub to work together, but these are separate services. So you will deal with IoT Hub, but it could be configured to work together with Azure Digital Twins service. Simulation and visualization is a part which absolutely fits to digital twins concept. So it is something which is used for IoT and not only for IoT. From another hand, we have business integration with other solutions, other components. It is something where we use digital twins like integration layer. And one of other important things is related to what we have as common data model. In IoT solutions, quite often we have essential part related to device configuration. So this common data model could be represented with Azure Digital Twins. And nowadays, as I already explained, Cloud Gateway offers only IoT Hub, and Digital Twins can be configured additionally, but it is not our front-end service from the back office. In 2020 at Microsoft Build was announced the second preview of Azure Digital Twins service. This version is improved and there are several important improvements actually. We have more flexible modeling. That means we have separate language for a model definition, which can be used for any kind of models. During the first preview, there were some preset objects which we can use mostly for smart spaces. Plus, we were able to define custom objects. But now you have absolutely agnostic to specific use cases and business domains approach. From another hand, exactly using digital twins definition language, we have more flexible topology. We can have much more complex relationships between different objects. We have, from another hand, richer and more flexible compute. I mean that we are able actually to call Azure functions and different endpoints from digital twins, and it is possible actually to have also scalability of computing which is used for digital twins analysis around digital twins. From another hand, we have decoupled IoT hubs, so it is possible also to scale IoT hubs. We have out-of-the-box support of high availability and disaster recovery. We have much more flexible options using IoT Hub separately with Azure Digital Twins. We have more standardized security in a similar way like for other services, and because we have no dependency to specific service in the core of digital twins, scalability is really much greater now. If we take a look at the documentation, there are some limitations related to number of requests per second, some limitations around what we can have like number of objects, relationships, and some other metrics, but most of these limitations are adjustable. That means you can have requests to Microsoft support and this limit can be considered and increased. Probably one of the most powerful features is this new language, Open Modeling Language, which is named DTDL, Digital Twins Definition Language. This language offers flexible modeling without any relationship and dependency to something preset. We have much better integration with live execution environment using Azure Functions. We have better integration as input and output from IoT and business systems and different services where we can store information after it is received at digital twins model. The overall design at this schema actually demonstrates what we have nowadays in Azure Digital Twins service. We have more simplified approach, we have more flexible modeling, we have more standardized options for security, multi-tenancy, and integration with other services. Additionally, you can use graphical interface. There is open source project Azure Digital Twins Explorer, and this Explorer is exactly Node.js application which can be used for importing models, for importing different object definitions. It is possible to edit your models using this application. It is possible to update what you have in digital twins instance in Azure, it is possible to clean your models. You have quite good representation using this open source project. So if you want to start, for most of cases, probably it will be more than enough to use this Azure Digital Twins Explorer. Of course, it is possible to use specific software. There are specific preprocessors created from Bentley MicroStation from one side and from ANSYS from another side for deep modeling for different products. It is possible to find also other options like separate products, but Azure Digital Twins Explorer comes for free and you can cover many cases using this free solution. Probably one of the most interesting points is how to use Azure Digital Twins service in modern IoT solutions. And let's start with preview from 2018 because for this preview we had Azure Digital Twins service in several roles. Again, like gateway service, that means you have IoT hub inside it and also like service which can be used for integration and for common data model. But most of solutions also were focused on smart spaces and managing of buildings and spaces just because this service offered as part of preset functionalities object model related to this business model. Uh, it is also important that this service offers data flow and processing related to integration with other services. So we had this functionality, of course, but in general, this coupling with several services and preset structures were probably the main limitation of this. In Azure Digital Twins preview from 2020, we have simplified and more clear design where we have integration between Azure Digital Twins and other services, mostly with Azure Functions or HTTP calls. Of course, we have several options to configure inputs and outputs, but in this way, using Azure Functions and HTTP calls, it is possible actually to integrate Azure Digital Twins with almost everything. We have out of the box options to configure some endpoints to event grid, service bus, for example, data grid, and from another hand, it is possible to have input from several different services. Another important point is to know how exactly Azure Digital Twins work in the context of event routing. So you have common flow where you have actually common event stream and you have event dispatching where you can have events um, collected from different services. There will be some specific logic using Azure functions or other custom services, and you are able to update the model after execution of this logic. So we have a common approach which we can apply for all cases in our digital twins. You can see here a typical example where we have collecting of data of different devices using Azure functions where these functions update some values in our digital twins model for specific objects based on uh, logic which we have around events. We can trigger Azure functions or again to call some another service where we will have some logic and we can update the models based on specific custom logic. We will see this scenario in the demos at the end of this presentation. Updating of the model can affect additional activities, and it is possible to have pushback to the original devices. We can have many iterations in this way and to provide quite complex logic to manage real-world solutions. When we use DTDL, Digital Twin Definition Language, we have several components which actually are used to build the whole model, and we are able to also set versioning of our models. I will explain the details a little bit later in this presentation. At the end of the overview of Azure Digital Twins in modern IoT solutions, I would like to cover two more cases. One is for device configuration management system, where digital twins is really very important. These kind of solutions are related to device monitoring, provisioning, and software update. And we have cases with multi-tenancy integration with other solutions and rising of alarms. Exactly in these scenarios, we can have digital twins and especially Azure Digital Twins. Common data model is something which can be represented with digital twins and to build the whole logic around this common data model. In the past, we needed to build custom solutions to represent common data model around device configuration management. Now we can just reuse Azure Digital Twins service for similar purposes. And again, multi-tenancy is another very important feature. Nowadays, we can have together IoT Hub and Azure Digital Twins to provide multi-tenancy around connectivity between devices where we have quite complex structure in the organization, usage of different organization, matrix structure, and to have a relative simple implementation, mostly because of Azure Digital Twins. And another interesting sample is when we have predictive analytics, we can integrate Azure Digital Twins service with another services for analytics to have these scenarios. We have similar use case where we use Anomaly Detector together with Azure Digital Twins service, and in this way it is possible relative fast and simple to implement predictive analytics. Because of the time limitation, we will be focused mostly on modeling for the latest Azure Digital Twin Service preview and what we have nowadays, like functionalities. All details can be found, of course, in the documentation, but you need to know several things. We have several important main components: property, telemetry, component, and relationship. Properties are actually backed up with some storage, so you are able in each moment to get a specific property and its value. Telemetry is something which comes and is changed continuously. We have data from different sensors, so it is slightly different. It is not possible to have historically some values for telemetry component. And we have component which is actually essential part of building of our model. Each component has interface and we are able to build our model like composition of different components, relationships between different parts of our model are actually implemented with specific element which is named relationship. When we have model, we have several fields which need to be used, identifier type of specific part. We have context for the JSON document where is used specific context for this digital twins definition language. We have optional display name, and all remaining interface data is placed in context. This is probably the um, high level uh, introduction what we have in our new modeling approach. There are several specifics. On the top level, DTDL elements in a model must be of type interface. We cannot define any commands. We can have only a single level of component nesting, and interfaces cannot be defined inline. Property and telemetry fields have several types possible which can be used. The main types are integer, double string, and boolean. We have option to use arrays and also to have object, map, and enum. Security is one of the most important features of Azure Digital Twins, as we will see at the demos later. We have several specifics. We need to grant permissions using role-based access control in the same way like for other Azure services. We have a process of authentication and authorization where we are using service principals. Internally, it is done via applications registered in the Active Directory, and finally, tokens is passed as part of the request to the Azure Digital Twins service. We have several roles, specific roles which are introduced only for Azure Digital Twins service. These are Azure Digital Twins owner and Azure Digital Twins reader. You need to use these roles exactly when you configure role-based access control for Azure Digital Twins service. The permission scopes can be applied on models, query digital twins graph, digital twin relationships, and event routes. And additionally, encryption of data at rest is implemented, and cross-origin resource sharing is not supported. You can have it, but with additional configuration which is custom and not out of the box. Few words about Azure Digital Twins high availability and disaster recovery. These features are available. We have inter-region high availability, which is out of the box, and cross-region disaster recovery. Again, all these features are managed from Microsoft, so you have no need to configure anything at the current moment to have these functionalities. At the end, we will have several demos, how to create digital twin systems, some details about models, how to create specific models inside the service, how to cure it, and real IoT solution sample with Azure Digital Twins. Let's now see how to create digital twin service. First, I will show you different options for Azure Digital Twins service, the old one and the new preview. So if we have filtering of our Digital Twins service, you can see that you have Digital Twins preview and Digital Twins deprecated. Let's see. I created already two different instances of the new one, and additionally I have one instance which is from the first preview. Um, if we go to the old one, you will see that we have management API endpoint, which is important. We have access control, where you can assign roles, for example, but here you do not see specific roles for Azure Digital Twins in general. And if we go back to the new one, we have a little bit different story. Here in access control, we have for add role assignments, Digital Twins owner preview and Digital Twins reader preview. So we have these two additional roles. Very important is to have security configured. So it is something which you really need to have when you deploy new Azure Digital Twins service. Another important feature is actually support the farm templates. You are able to have deployment integration with CI/CD in a similar way like for other Azure services. I would like to remind you that the first preview didn't support this functionality. Let's now try to create a new instance of Azure Digital Twins so we can try to find the right service. You see that for Azure Digital Twins this is available. If we use even only Digital Twins, you see that the old version is not available anymore for creation. So you will be able to continue to use your existing instances, but not to create new one. And we need to have several settings here. You need to choose the subscription. You need to choose the resource group. If it is needed to create some specific, you need to configure the region. Not all regions are available, but you have already several in Europe, so you can have North Europe, West Europe, UK South. You have several regions in US, Australia, and Southeast Asia. I will create in West Europe a new one. So we need to give additional name for our service. For example, Azure Digital Twins from 2020, third instance. And at the last step, you need just to create this service. I will not wait for creation of this service. We'll go ahead and we'll show you several more things which are important related to security which you have for Azure Digital Twins. Because Azure Digital Twins works with service principles, we need to have in our Active Directory registered applications. If we go to app registrations, I will show you now we have already such kind of applications available. Uh, this one, ADT 02 2020, will be used for our IoT example. And you can see when we have such kind of applications, several important things. First, you need to have platform configurations. You need to have configuration for different um, platforms, mobile, desktop, web. You can add additional platforms and you need to add specific endpoints. Here I added localhost with specific port for web applications and only localhost for uh, mobile and desktop applications. When you deploy your clients somewhere in the cloud, you need to have appropriate endpoints. These endpoints now are configured only for test purposes because I will execute the samples from my local machine. Additionally, you need to consider also API permissions. So you need to have Azure Digital Twins read to write here like permissions which are supported, and also you need to have from the overview your application client ID here, and also your tenant ID. So all these components will be part of settings which you need to configure for sample applications. I already built and deployed the sample Azure Digital Twins Explorer. So we have this application running locally and port 3000. And we can open our browser at this address, and I already had some login, but let's try to query our Digital Twins service. During the initial login, you need to add parameters for client ID, for tenant ID, and endpoint of your Azure Digital Twins service. You see here that we have different parameters for each component. It is a very simple example, which is preset, where we have different properties, and we have specific values for these properties. You can see for thermostat here we have some metadata, where for temperature we have some information, last updated date, and some other values. I have prepared device simulator project which sends simulated data to our Digital Twins service. So I will start our sample application, and you will see here we have different messages for the temperature. We have all this information in Azure Digital Twins currently. Additionally, I have sample client of Azure Digital Twins service, which is configured with the proper settings to be possible to be connected and to get data from Azure Digital Twins service. Now we will check the temperature of the observed thermostat, which is number 67. So we will make this check. And you see, we have here actually received information, including temperature, from our Digital Twins model. So you have, in such way, real end-to-end scenario where we have IoT solution from one sample device. We are sending information via IoT Hub, which is outputted using Azure function to Azure Digital Twins. And from another hand, we have Azure Digital Twins client which consume this information. To be possible to establish connection between Azure Digital Twins and IoT Hub, we are using here Azure function which gets from the environment specific settings to be possible to send data to Azure Digital Twins service. The whole configuration of this sample requires a little bit more time. That's the reason to show you mostly the preset configuration and to not follow step by step the whole process. And at the end, I would like to show you more complex models already deployed to Azure Digital Twins service. So I will refresh our browser to be sure that we have no anything additionally and can run this query, select everything from Digital Twins. Our Azure Digital Twins Explorer is already configured with the right connection to another instance of Azure Digital Twins service, which has already created. I'm trying to establish connection now, and you see that the whole model now is loaded. The whole solution is probably the more correct because we have here solution which contains many different models. So you can upload different models, you can have quite complex solution, and you are able to observe specific elements and to see what exactly is available. We have from one side model which represent network of electricity, and we have the same model which you saw about the end-to-end IoT example. Additionally, you can see at the left side different models which are loaded from local disk. Models are actually in DTDL format. You can have more complex solutions in Excel file where you are able via this Azure Digital Twins Explorer to upload the whole solution. I will provide you some examples for model definitions. For example, this is the description of base consumer where we have ID, context, version first of this definition, display name, and everything else in context where you have type, name, and you can have additional data. Based on base consumer, we can have another model, domestic consumer, which actually is inheriting the first one, and you can add additional information in the new model. You can load in Azure Digital Twins Explorer solutions which contain different models. It is supported uh, solution definition where you have everything in Excel format. So you can describe your solution in Excel table, and it is possible to import it and to have everything in Digital Twins service with few clicks. That was everything in this presentation. Thank you for watching and feel free to contact me if you have any questions.